Hi guys, I'm back with another arcade repair video, and today we're going to look at Atari System 1 Road Runner game cartridge, which I just got in the mail. I bought it on eBay and I got it quite cheap again. It was sold as non-working, and in this video we're going to try, as always, to troubleshoot the game. Go through our trial and error process step by step, and of course try to get the game working again. As always, I'm going to try to explain everything I do so that this might help you with your own arcade PCB repairs. I already talked about the Atari System 1 in general in another repair video I did, which was the Indiana Jones video. Basically, the Atari System 1 was an arcade game system which Atari released in the early 90s, which shared a common game motherboard and a common arcade cabinet, and you could switch to different games. I think there was 5 games released in total, just by exchanging the game cartridges, which is what you see here for the Road Runner game. This is the game cartridge. And you could also exchange the control panels and the marquees. And the control panels were different. They had joysticks, they had a trackball version, and they had a version with a steering wheel. The most successful games, I think, were the Indiana Jones, the Road Blasters, and the Marble Madness game, of course. Okay, we're going to hook up this cartridge PCB to a mainboard PCB I have and go for a test very soon. But just before we start, I actually wanted to point out something that I already noticed before I even got the PCB in the mail, because it was also clearly visible on the auction photo which the seller had put up, is that there's actually at one spot on the board there's actually an IC missing, which is surely preventing the game from running. The Atari System 1 cartridge boards tend to have unpopulated IC sockets all over the place. Actually, this is not uncommon, and that is not a problem. Depending on the game, certain areas are just unpopulated. And I think for the Roadrunner game, the graphical ROM set looks pretty much complete. For the sound part, we are missing this EEPROM over here, but I also think that this is right. But what you can see up here, this is the part where the program code for the game is stored. You can see that there's those 2 EEPROMs missing. This should be okay, but what cannot really be alright is that this single EEPROM here is missing, because we have 2 rows of EEPROMs here which contain the program code, and as marked on the PCB, you can actually see here it says upper and here it says lower. This is the so-called lower bank of EEPROMs, and this is the upper EEPROM bank. And what that actually means is that for each address in the EEPROM's range, the main processor of the game, which is a Motorola 68000 processor, which is a 16-bit processor, is expecting to have access to 16 bits of data. And those EEPROMs usually only have 8 data lines. So for a 16-bit game, there's actually 2 EPROMs required for every address. One is carrying the lower 8 bits, like bits 0 through 7, and the other one has to carry the upper bits, which is 8 through 15. That's why this is called the lower bank and the upper bank. And those EPROMs can be regarded as pairs, because those 2 EPROMs here are covering the same address range, but are addressing different bits of the parts of the data, the lower and the upper part. Those are a pair, those are a pair, those are a pair, those are a pair. But there we have the problem. Here is a certain address range in the EPROMs that has upper bits and no lower bits. That can't be right, of course. That doesn't make any sense. So either this EPROM doesn't go in this spot, or this one is missing. And I actually do know that this is the lowest part of the program's address range here, and these EPROMs are actually where the game code really starts. So I'm knowing that I can tell that this EPROM is surely missing, and the game, as it's actually the starting code for the game, this PCB can't be running. You can tell by just looking at it. So, and the good thing about this is that we actually have something to go on just before we even really started troubleshooting and attaching our probes or our logic analyzer and whatnot. And we can actually, before we fiddle around much with the board, we can already replace this missing EPROM and then hook up the board and go for a test. Well, knowing that this EPROM is crucial and that it is missing doesn't actually really mean that if we replace this missing EPROM that the game will be running. Of course, there's no guarantee, but there's a possibility, and sometimes sometimes it works, and so maybe we are lucky and this will be a quick repair. Okay, I hooked up the cartridge to my Atari System 1 mainboard, which you can see here. Hooked up the power, hooked up the video signal, and connected it to my new tiny, neat testing monitor, which I got. I actually had to do a repair on this monitor as well, but I unfortunately didn't record a video about it. Okay, but now I just turned the power on, and okay, we can actually see something. The System 1 says there's no cartridge. So I would actually have expected that there's just garbage on the screen, but well, the System 1 mainboard itself has some code on some ROMs here, which actually seem to be able to detect that there's no valid code or valid game connected, so it can produce this error message. But well, as expected, it's not running, so we'll have to get a replacement for this missing EPROM. Okay, so how do we know which EPROM to put there, what kind of IC it needs to be, what kind of data needs to be programmed on the EPROM? It's actually quite easy, because those EPROMs are all numbered on the board. And there's a certain system going on here with the numbering. You can see here what kind of ICs are used, and this is a 27256 EPROM for the upper bank. As those two have to cover the same address range, I would have to expect that the same chip has to be in place here. So we are going to try to find 26256 in my spare EPROM chips collection. in a moment. And well, regarding the data we have to program on the chip, we can see that there's numbers here, and for instance here it's 134, and here it's 135. We have 230 here, 231, 136, 137. So this lower bank, actually the number for the lower bank actually seems to correspond to the number of the upper bank, but it's just increased by 1. So 135 is 1 higher than 134, and 231 is 1 higher than 230, and so on and so on. So if we have 228 here, we would expect to be missing an IC with the number 229. So we can actually go to the main ROM collection for the road and look in the Roadrunner zip file, and we can look for a file which is somehow labeled 229, and we can burn it on a 27 to 56 EEPROM, and we should be good to go. Okay, so I checked my MAME ROMs collection, and I found this archive over here, roadrun.zip, and sure enough, it contains a file labeled 131640 229.11a. 11a should be the position of the EEPROM on the main board, so we can actually double check if that is correct. So A would actually be this row. This seems okay, and 11 is right there. So 11A, that's the spot. So let me grab a blank EEPROM and program it with a file, and maybe the game is running. Let's see. Okay, so the EEPROM, the replacement EEPROM, is programmed and in the socket. Let's check it out. Okay, okay, so we got a bank switch error, ROM at 20,000, 28,000, 70,000 and 78,000. Okay, so we don't seem to be completely lucky because we're not done yet, but we got a bit further, of course, and well, we seem to have some faulty ROMs, some more faulty program ROMs in the upper bank at those addresses, and to find out which of the EEPROMs actually correspond to these addresses, I'm going to remove the EEPROMs of the upper bank chip by chip, and I'm going to check how the error messages are actually changing, and this way we can determine which of the EEPROM chips might still be problematic. Okay, so for instance, after removing this EEPROM from this spot over here, I get another error message, ROM at 60,000 and 68,000 error. So this ROM should be corresponding to that address. So I'm assuming that this EEPROM is probably alright, because the error isn't detected when the EEPROM is in the socket. Okay, so but when I remove the EEPROM next to it, the error messages don't really change. So I'm assuming that this EEPROM here should belong to those addresses 20,000 and 28,000. So I'll put this aside for now, and I'll do another test. I will remove the corresponding lower bank EEPROM. Okay, if I remove the lower bank EEPROM, we can see that we have the ROM error 20,000 and 28,000, not only in the upper but also in the lower bank. So this should be, we should be safe to assume that this EEPROM is belonging to 20,000 and 28,000. So, and in the same way I'm going to try to look for the other EEPROM here. Okay, so the address range 70,000 and 78,000 seem to belong to those sockets here. So I removed this one, I removed this EEPROM, and I will now try to read their contents and compare them to my main ROMs and see if this shows an error with these EEPROMs. So after reading the contents of those two EEPROMs, 138 and 230, I compared it with my main ROM collection, and there's actually, for both ROMs, there's a match with the Roadrunner ROM set. So we have to say that those ROM chips are actually all right. Well, and interestingly, after putting them back in the socket, both of them, one of the errors disappeared. The error 70,000, 78,000. So this ROM now seems to be all right somehow, while this EEPROM over here still seems to be problematic. Well, if the EEPROM chips themselves aren't faulty, the second possibility is, of course, that there's problems with the IC sockets. So I think I'll have to take a closer look at the socket of the IC belonging to that faulty address range, and maybe just go ahead and replace it, and then give it another go. Okay, so I removed the socket, and on one side of the pins you can't really even see the metal contacts. It's pretty dirty, and also I don't know if you can see it, but when I removed the socket, one of the legs actually lost its tip. It's right over here, so maybe this leg was actually broken and not making any good contact. Anyway, I put a new socket in, which is this one over here. It's a different, slightly different version than the sockets that are normally used on the board. It's actually a better version of a socket where you have metal contacts that are touching the pins of the ICs from both sides, so contact should be generally better in this kind of socket. Okay, so let's put the EEPROM 230 back in, and let's take a look if we get any further. So EEPROM is back in. Let's see. And there we go. Very nice. So the game is running again. And well, one more thing I would like to mention, which might have actually been crucial for this repair also, is those jumpers, 6 sets of jumpers, which are located next to the EEPROM banks, and they are actually used to select the size of the EEPROMs that are in the sockets. And they are the same for all different Atari System 1 games. So on some game boards these jumpers might be configured differently than on other game boards. But what they all have in common, they are actually a little bit higher than the EEPROMs. They're reaching out a little bit more. And what surely can happen is, if the EEPROM cartridge is stored on a shelf or in a package or wherever, that the cartridge comes to rest on those jumpers, and so those jumpers are mechanically stressed, particularly, and those jumpers seem to tend to have bad solder connections on the solder side of the PCB. So I did reflow all of the solder on those connectors as well, and I didn't really, I wasn't really able to see any cracks in the solder, but I would actually recommend this as a standard practice if you have problems with these EEPROM banks, to reflow the solder on those jumpers. This actually did also help, I think, on the Indiana Jones repair that I did before. Okay, so overall I'd say it was quite an easy repair, just replacement of one EEPROM, some error messages regarding the other EEPROMs, which led to the replacement of a socket, and reflowing the solder on the jumpers, and everything is working fine again. So thank you very much for watching. I hope this video might help you in the future if you come across an Atari System 1 board which isn't running. And well, if you liked the video, please feel free to watch my other repair videos and subscribe to my channel, and of course leave comments below if you got any questions. I'm happy to answer them. So, well, yeah, thanks again for watching.